Hello students, welcome to the interesting chemistry where you will find a feeling of classroom teaching, and besides you can also enjoy a classroom teaching from your study room. In continuance of the redox reactions, today I am going to explain you the equivalent weight of the oxidant and reductant. I hope that you have watched my previous video in which I have explained about the oxidation reduction, oxidation number and the balancing of the redox reaction or the ionic reactions by the ON method, oxidation number method or ion electron method. Today I am going to explain the equivalent weight of the oxidant. This is the formula of the oxidant. Equivalent weight of oxidant is equal to molecular weight. If that is compound, then you will take molecular weight. If that is an atom or an element, then you will take atomic weight. Or if you have to calculate the equivalent weight of an ion, so you can take the weight of ion upon, as you know, oxidants gains electron, so gain of total electron or decrease in oxidation number Now I will tell you with some examples. Suppose it is MnO4 or it is in acidic medium, MnO4 1 negative, it changes to Mn double positive. It is an oxidant. So here the oxidation number of Mn is +7 and here the oxidation number of Mn is 2. So the decrease in oxidation number is equal to 5. 7 minus 5. So if you want to calculate the equivalent weight of KMnO4, this is KMnO4. Calculate the molecular weight of KMnO4. You can calculate. This is 39, Mn 55 and 64. So please KMnO4 calculate. 4, 9, 9, 18 and 6, 11, 13, 14, 158. It is 150. The molecular weight of KMnO4 is 154. So the equivalent weight of KMnO4 in acidic medium is equal to 158 molecular weight. The molecular weight of KMnO4 is 158 and the decrease in the oxidation number 5. So 5, 13, 1, 1.6. The equivalent weight of KMnO4 in acidic medium is 31.6 with the decrease of oxidation number. If you want to calculate with the gain of electrons, then you will write here MnO4 1 negative plus 8H. Due to the presence of 4 oxygen, you will add 8H positive from the acidic medium. So this Mn double positive plus 4H2. This will be your equation. Now balance the ion of the equation. Here are 8H positive. So you have to add here 5 electrons, 5 negative and 1 negative, 6 negative, 8 positive, 2 positive are here and 2 positive are here. So you have balanced the equation with by adding 5 electrons. So again, gain of total electrons are 5. So you will divide the 158 by 5. Again, the equivalent weight of KNO4 will be 31.6. If you want to calculate the equivalent weight of iron, MnO4 1 negative, MnO4 1 negative equivalent Mn55 plus 64. 55 plus 64, 119. 5, 9, 6, 11, 19, and divide by 5. So the equivalent weight of MnO4 is 5 into 2, 5, 3, and 5, 8. 23.8. In this way, you can calculate the equivalent weight of KMnO4 in acidic medium. If somebody says, if question is asked in your examination, what is the equivalent weight of KMnO4 in basic medium? So you have to write the next other equation. Next equation. So MnO4 in basic medium. How will you write the equation? This is MnO4 1 negative, and it changes in the MnO. So you will write this equation. MnO4 1 negative changes into MnO2 in the basic medium. Basic medium. So again, calculate the total gain of electrons or decrease in the oxidation number. So here oxidation number is +7, and here oxidation 2 minus 4 is 4. So the decrease in oxidation number 3. So calculate. The equivalent weight of KMnO4 in basic medium will be 158. The molecular weight just I have calculated 158. Divide by 3. So 3, 5 and 6. So he will write here 2 and 26. It's in this way the equivalent you have to divide by 3. And again, in the basic medium, you can write the only 3 electrons will be gained by MnO4 in the basic medium. So you will divide 158 by 3. It is the equivalent weight of KMnO4 in basic medium. So if a question asked to you in your examination, what is the equivalent weight of KMnO4 in basic medium, so you can calculate 52.6, and in acidic medium, that is 31.6. Now I am telling you about the potassium dichromate. Calculate the equivalent weight of potassium dichromate. How in acidic medium? As you know that the potassium dichromate reacts only in the acidic medium, so you will calculate the equivalent weight of potassium dichromate only in acidic medium. So what is the equation? You should know this is the equation Cr2O7 double negative and 2Cr triple positive. This is the equation. So calculate the oxidation number of chromium. Here the number of chromium is 2x minus 14 is equal to 0. So x is equal to, this will be the +6, and here +3. So the decrease in ON is equal to 3. Decrease, but it will be wrong. Now you should divide the molecular weight of the potassium dichromate with the total gain of the total decrease in oxidation number. Here total decrease, you can again I stressed on the total in my previous video, total decrease in. So here the total oxidation number of 2 chromium will be 12 plus 12. The total number of chromium, the oxidation number of chromium is 2 into C plus 6. So the total decrease is equal to plus 6. Total decrease is plus 6. Now calculate the molecular weight of chromium C2R207, the 39 and Cr252, 104 plus 112. So calculate this K2, 78. This is K2, here are K2 78, 112, 78, 190 and 104, 294. 294. So the equivalent weight of K2Cr207 is equal to 294 divided by 6, not by 3. Divide by 6. Because the total decrease in the oxidation number is 6. Here, in 1 chromium decreases 3. The oxidation number decreases in 1 atom of the chromium. But here I taken 2 chromium are there. So you will divide by 6. So the equivalent weight of 6, 4 and 9. So 49. So 49 is the equivalent weight of potassium dichromate in acidic medium. I think that you have understood how will you calculate the equivalent weight of KMnO4, K2Cr207 in acidic medium and KMnO4 in basic medium. Now I am going to explain you about the equivalent weight of reductant. This one is reductant. So formula will be the same. You can write here reductant. Reductant is equal to only molecular weight same, atomic weight same, or weight of ion same. Here gain of total electrons only, you will write here loss of total ES. Here loss, change this gain into loss, and here decrease, so total increase, you will write here increase. I think that you following me, and you understand what I am going to tell you. Again, don't go my handwriting, but please try to understand. The oxidant are just opposite to the reductant, and reductants are just opposite to the oxidant. So the molecular weight, atomic weight, or the weight of ion will be the same formula. But here gain of total electrons, here you will write the loss of total electrons. Here the total decrease in the oxidation number, you will write here total increase in oxidation number. So how will you calculate? So here take the example. Suppose it is the MnO4. MnO4 one negative plus Fe double positive. So here Fe triple positive, Fe triple positive plus Mn double positive. Here Fe gets oxidized. Here this is a oxidation reaction. Oxidation reaction. But Fe acts as reductant. Reductant because it is oxidant and the Fe will act as reductant. So the gain of Fe changed into Fe triple positive. So here Fe will lose one electron to form Fe triple positive. So only one electron. So what is the equivalent weight of Fe in this case? So the atomic weight of Fe is 56. Equivalent weight of Fe is equal to the atomic weight of Fe is 56 and it is divided by 1 because is lost only one electron. And also in total increase in oxidation number here is 1 because here plus 2 and here plus 3. So the increase in oxidation number is 1 and the loss of electron is only 1. So the atomic weight of Fe will be divided by 1. So the equivalent weight of the Fe will be 56. Again, the molecular weight and the equivalent weight of the Fe are similar, 56. Now I am going to tell you about the second, oxalate ion. Oxalate, what is the oxalate? How will you calculate the oxalate? Oxalate ion. This is oxalate ion COO negative minus 2 electron CO2. So here is the loss of 2 electron. Here in this case the loss of 2 electron. So the molecular weight of oxalic acid will be divided by 2 and you can calculate. And again, if you want to calculate the equivalent weight of the oxalate ion, the total weight of ion divided by 2 because the loss of electrons is 2. Again you can say it is the oxidation number is minus 2 and here the oxidation number is 0. So again there is an increase of total increase of the oxidation number is 2. So the molecular weight of oxalic acid will be divided by 2 and the weight of the ion, oxalate ion, also divided by 2 to get the equivalent weight of oxalic acid and oxalate ion respectively. So I think that you have understood what I explained today, the equivalent weight of oxidant and reductant. That's all for today. I think that this video is very useful to you if your questions is asked in your examination that what is the equivalent weight of K1O4 in the basic medium. How will you calculate? I told you today. So please go through my video from start to end. I am not taking the blackboard, the messy work of the blackboard. I don't, but I am trying to make you understand. I think that you have understood what I want to tell you. That's for all today. Thank you very much.